Hello there, and welcome. I am the sleepy astronaut. I'm so glad you found your way here. Maybe you have had a rough, draining day, or maybe you just love learning about space and time. Either way, tonight's journey is for you. This evening, we will be learning about all of Jupiter's many, many moons. I am coming right down to Earth to pick you up. Tonight, we are staying close to home, visiting the giant of our solar system, Jupiter, and its vast family of orbiting worlds. There are now known to be at least 95 moons of Jupiter, with more being discovered all the time. We will visit as many of them as we can, one by one, in a long, quiet, patient journey through the Jovian system. It is a slow, gentle flight through the dark, designed to let your mind wander and your body sink into rest. If you enjoy these calm journeys through space, I invite you to subscribe or leave a thought below. It helps other astronauts find their way here. But for now, your day on Earth has come to an end, and your journey through the stars has begun. You don't need to do anything, just relax and let your body sink. Let your eyes grow heavy and allow your mind to drift into space. Let's take off. We leave Earth behind, drifting outward through the quiet dark. The sun grows smaller behind us, fading to a bright, steady star. We pass Mars, rust-red and still, and across the asteroid belt, that quiet highway of drifting rock and silence. And then ahead of us, something immense begins to take shape. Jupiter. It is the largest planet in our solar system. Over 1,000 Earths could fit inside its vast, swirling volume. It is a world of gas and storm, of endless cloud bands painted in creams, ochres, and soft browns. Its surface is not a surface at all. It is an ocean of hydrogen and helium, compressed to unimaginable depths, with no solid ground to stand upon. If you descended into Jupiter, you would sink forever through layers of thickening atmosphere, through crushing pressure and rising heat, until the very air became a liquid, then a metallic ocean, glowing with the heat of a dying star. And at its heart, a core of heavy elements, perhaps 10 times the mass of Earth, hidden beneath layers of mystery. Jupiter's atmosphere is a masterpiece of chaos and beauty. Its cloud bands are divided into dark belts and bright zones, each one a river of gas flowing in opposite directions at hundreds of miles per hour. The Great Red Spot, a storm larger than Earth itself, has been raging for centuries, perhaps even longer. It is a swirling vortex of crimson clouds, a hurricane so vast that it could swallow our entire world and still have room to spare. The winds within it reach speeds of over 400 miles per hour, and its eye is a silent, dark void at the center of the storm. Yet even this colossal storm is slowly shrinking, its edges fraying like a worn tapestry, a reminder that even the most enduring things in the cosmos are subject to the slow passage of time. Jupiter is a giant in every sense. It is so massive that it bends the orbits of comets and asteroids, shielding the inner planets from countless impacts. It is so massive that it pulls its moons into tight, captive orbits, a family of worlds bound to their parent by a gravitational grip that has held them for billions of years. Without Jupiter, Earth might not exist. Without its gravitational shield, our world would have been struck by far more comets and asteroids, and life might never have had the chance to take root. Jupiter also possesses a system of faint, dusty rings, much less dramatic than Saturn's. but beautiful in their own right. They are composed of tiny particles of dust, thrown off by its inner moons. The main ring is broad and tenuous, while the halo ring and the gossamer rings extend outward in a delicate, almost invisible embrace of the giant planet. These rings are a testament to the ongoing activity within the Jovian system, a slow dance of dust and light that has been unfolding for billions of years. The planet's magnetosphere is the largest structure in the solar system. It is so vast that it would extend beyond the orbit of the Sun, if the Sun were visible from its outer edges. This magnetic bubble traps charged particles, creating intense radiation belts that would be lethal to any unprotected spacecraft. The aurorae at Jupiter's poles are a breathtaking display of light, far more powerful than the aurorae on Earth. Their colors dancing in the dark, a silent symphony of electromagnetic energy. The Juno spacecraft has been studying this magnetic environment, revealing the intricate nature of Jupiter's magnetic field and how it interacts with its many moons. But tonight, we are not here to marvel at Jupiter alone. We are here to visit its family, the nearly 100 known moons that orbit it in a silent, endless dance. Jupiter has so many moons because of its immense gravity. When the solar system was young, Jupiter's gravitational field was so powerful that it captured passing worlds, pulling them into orbit. Some of these moons are as large as planets. Others are tiny fragments of rock, no bigger than a city block. They orbit at different distances, some close enough to skim the edge of Jupiter's atmosphere, others so far away that they feel the Sun's gravity almost as strongly as Jupiter's. The process of capture was likely a violent one, worlds torn from their original orbits, their trajectories abruptly changed by the immense gravitational pull of the nascent giant. Some collided and shattered, their fragments forming the clusters of irregular moons we see today. Others were slowly gentled into their current orbits, their energy dissipated by tidal forces over billions of years. And each one of them, from the largest to the smallest, is a world of its own. Let us visit them now, one by one. We begin with the largest four. These are the worlds that Galileo first saw through his telescope in 1610. They are the crown jewels of Jupiter's family, worlds of fire, ice, and hidden oceans. The first is Io. Io is a world of fire. It is the most volcanically active body in our solar system. Its surface is covered in sulfur and lava, its landscapes painted in streaks of orange, yellow, and red. Hundreds of volcanoes erupt across its surface at any given moment, spewing plumes of gas and ash hundreds of miles into the void. It is thought there could be as many as 400 active volcanoes on Io's surface, making it the most volcanic place in the entire solar system. Io is caught in a gravitational tug-of-war between Jupiter and the other moons, Europa and Ganymede, and this constant stretching and squeezing heats its interior, driving its volcanic fury. The lava from these eruptions can exceed 1,000 degrees Celsius, hotter than most volcanic eruptions on Earth. Some eruptions produce lava fountains that reach temperatures hotter than anything found on our planet, and the plumes of sulfur and ash can arc hundreds of kilometers into the sky. The surface of Io is in a constant state of renewal. its volcanic activity erasing craters and reshaping the landscape on timescales far shorter than any other known world. Io has a thin atmosphere, composed mostly of sulfur dioxide, which is constantly being replenished by its volcanic activity. This atmosphere is a fragile envelope, tenuous and fleeting, yet it creates a remarkable phenomenon. The Moon's interaction with Jupiter's magnetosphere generates a powerful electric current, creating lightning in its upper atmosphere and stripping away material into the vast magnetic environment of the giant planet. This material forms a torus, or donut-shaped cloud, of particles that orbits Jupiter along Io's path. The Galileo spacecraft, which orbited Jupiter from 1995 to 2003, detected that Io's surface is a patchwork of volcanic plains, mountains, and lava lakes, some of which are among the hottest spots in the solar system. It is a world of restless fire, a glowing ember in the dark. We drift past Io, feeling its heat through the void, and leave it to its fiery dance. The second is Europa. Europa is a frozen world. Its surface is a shell of ice, smooth and cracked, crisscrossed by dark lines and ridges. The surface is remarkably young, with few impact craters, indicating that it is geologically active. The cracks, known as lineae, are thought to be caused by the gravitational stresses of Jupiter's tides, which flex and deform the icy shell. These ridges and cracks are like the surface of a frozen sea, a landscape of fractures and chaos terrain where the ice has been broken and refrozen into jagged patterns. The surface temperature on Europa is a frigid -260 degrees Fahrenheit. Yet beneath that ice lies something extraordinary, a global ocean of liquid water, heated by the same gravitational forces that torment Io. It may contain more water than all of Earth's oceans combined, and where there is water, there may be life. The search for life on Europa is one of the most exciting scientific endeavors of our time. The ice shell covering this ocean may be tens of kilometers thick, with the liquid water ocean below extending perhaps 100 kilometers deep. The Juno spacecraft has provided new measurements of Europa's subsurface structure, helping us understand the thickness of its icy shell and the nature of the hidden ocean below. Evidence from the Hubble Space Telescope has suggested the presence of water vapor plumes erupting from the surface, similar to the geysers on Enceladus at Saturn. These plumes, if confirmed, would provide a direct way to sample the ocean below without having to drill through the thick ice shell. The Europa Clipper mission, set to launch in the coming years, will orbit Jupiter and perform multiple flybys of Europa, studying its ice shell, its ocean, and its potential to harbor life. Europa is one of the highest priority targets in the search for life beyond Earth. We float past Europa, imagining that hidden ocean, and leave it to its silent, frozen mystery. The third is Ganymede. Ganymede is the largest moon in the solar system. It is larger than Mercury, larger than Pluto, a world in its own right. Its diameter is about 3,270 miles, or 5,260 kilometers. It orbits Jupiter at a distance of about 665,000 miles. It has its own magnetic field, a rare thing for a moon, a discovery made by NASA's Galileo spacecraft in 1996. The magnetic field causes auroras, ribbons of glowing, hot, electrified gas, in regions circling the north and south poles of the Moon. This magnetic field is thought to be generated by convection of liquid iron in its metallic core, similar to the process that generates Earth's magnetic field. The presence of this field suggests that Ganymede is differentiated, with a metallic core, a rocky mantle, and a thick shell of ice. Beneath its icy shell, scientists believe there may be a salty ocean hidden in the depths, with more water than all the water on Earth's surface. The ocean is estimated to be about 60 miles thick, 10 times deeper than Earth's oceans, and is thought to be buried under a 95-mile thick crust of mostly ice. This ocean is believed to be a result of tidal heating, similar to Europa's ocean. NASA's Juno mission has also observed mineral salts and organic compounds on the surface of Ganymede, offering clues about the composition of its deep ocean and the history of this frozen giant. Its surface is a patchwork of dark, ancient craters and bright, grooved terrain, evidence of a history of tectonic activity. The dark regions are heavily cratered, dating back billions of years, while the bright regions are younger, with grooves and ridges that suggest episodes of resurfacing. Ganymede is a world of contrasts, a frozen giant with a hidden ocean, a magnetic field, and a complex geological history. We drift past Ganymede, the giant of the Jovian system, and leave it to its slow, quiet orbit. The fourth is Callisto. Callisto is the oldest, most cratered world in the solar system. Its surface is scarred with billions of years of impacts, a frozen record of the early solar system. It is the most heavily cratered object in the solar system, its surface pockmarked with craters of all sizes, some with great rings around them like ripples in a frozen pond. Callisto is made up of roughly equal parts rock and ice. Its surface of ice and rock is the most heavily cratered of any moon, signifying that it is geologically dead. There is no evidence of the volcanic activity or tectonic shifting that have reshaped the other large moons. Unlike the other Galilean moons, Callisto's interior is not differentiated. Its rock and ice are mixed together like a raisin pudding, instead of having a distinct core and mantle. This suggests that Callisto never experienced the level of heating necessary to separate its materials, remaining a largely pristine relic of the early solar system. It has a weak magnetic field induced by Jupiter's field, which raises the possibility that a salty liquid water ocean exists somewhere below its surface. However, this ocean, if it exists, would be much deeper than those on Europa or Ganymede, lying perhaps 200 kilometers below the surface. The pressure at that depth would be immense, but the water could still be liquid due to the presence of salts or other impurities. Callisto has a diameter of about 3,000 miles, less than 60 miles shy of the diameter of the planet Mercury. It has remained substantially unaltered inside and out for the past 4 billion years. It is a world of stillness, of patience, of deep time. The Voyager and Galileo missions provided our first close-up views of Callisto's ancient surface, revealing its incredible age and the violent history of the solar system. We drift past Callisto, feeling the weight of its ancient silence, and leave it to its endless orbit. We have visited the 4 giants. There are many more moons to see. Let us continue our journey. Beyond the 4 great Galilean moons, There are smaller worlds, moons that orbit closer to Jupiter, racing through the dark in tight, hurried paths. These are the inner moons, the Amalthea group. The closest of these to Jupiter is Metis. Metis is the innermost of Jupiter's moons. It was discovered in 1979. It orbits so close to the planet that it skims the edge of its atmosphere, circling Jupiter in just 7 hours, less than one Earth day. It is a tiny, irregular fragment of rock, about 21.5 kilometers in radius, caught in a tight, desperate orbit. Its shape is elongated, like an asteroid, and its surface is dark, reflecting little of the sunlight that falls upon it. It orbits within Jupiter's main ring, and it is thought to be a source of material for the ring itself. Next is Adrastea. Adrastea was also discovered in 1979. It is one of the smallest moons in the solar system, just a speck of rock, barely 8 kilometers in radius. It orbits at the edge of Jupiter's main ring, sweeping up dust and debris as it circles its giant parent. It is a shepherd moon, guiding the particles of the ring into their graceful path. Its small size and irregular shape suggest it may be a fragment of a larger body, perhaps the result of a collision long ago. Next is Amalthea. Amalthea was discovered in 1892 by Edward Emerson Barnard, the fifth known moon of Jupiter. It is a small, irregular world, shaped more like a potato than a sphere, with a radius of about 83.5 kilometers. It orbits just outside Jupiter's main rings, in the space between the gas giant and its larger moons. Its surface is dark red, covered in craters and scarred by impacts. This red color is thought to be due to the presence of sulfur compounds, perhaps deposited by volcanic activity on Io or from impacts of sulfur-rich material. It is a captured asteroid, a fragment of rock that fell into Jupiter's gravitational grip long ago. Amalthea has an elongated orbit, and it is thought to be a source of material for Jupiter's gossamer ring. And finally, Thebe. Thebe was discovered in 1979. It is another small, irregular moon, with a radius of about 49 kilometers, orbiting between Amalthea and Io. It is dark and cratered, its surface coated in dust and debris. It drifts through the void, a silent traveler in a busy system. Like Amalthea, Thebe is thought to be a captured asteroid, and its dark surface reflects little light. Thebe's orbit is also elongated and tilted, a common feature among Jupiter's irregular moons. It also contributes material to the gossamer ring. These are the inner moons, small, dark, and swift. They race through the dark, never pausing, never resting, caught in the endless grip of Jupiter's gravity. We drift past them one by one and continue our journey. Beyond the Galilean and inner moons, Jupiter's family becomes stranger. There are dozens of irregular moons, distant, captured asteroids, and fragments of rock that orbit Jupiter in long, elliptical paths, often moving in the opposite direction from the planet's rotation. The first of these outer moons is Themisto. Themisto was discovered in 1975. It is a solitary traveler, a small, irregular moon with a radius of about 4 kilometers. It orbits between the inner and outer groups, a quiet loner in the vast Jovian system. It takes about 130 days to complete one orbit around Jupiter. Its orbit is highly inclined, and it is thought to be a captured asteroid. We drift past it, leaving it to its solitary journey. Then there is the Himalaya group, a cluster of moons that orbit together in a similar region of space. They are likely fragments of a larger body that was shattered by a collision billions of years ago. The largest of these is Himalaya itself. Himalaya was discovered in 1904. It is a small, irregular moon with a radius of about 85 kilometers. It is one of the largest of the outer moons, and it orbits Jupiter at a distance of over 11,461,000 kilometers. It takes about 250 days to complete one orbit around Jupiter. It is a captured asteroid, a wanderer that fell into Jupiter's gravitational embrace and never left. Its surface is dark and likely primitive, resembling the surfaces of carbonaceous asteroids. Then there is Elara. Elara was discovered in 1905. It is a smaller companion to Himalaya, with a radius of about 43 kilometers. It is a fragment of rock, perhaps broken from a larger body by an ancient collision. It drifts in the dark, a silent traveler in the outer reaches of the Jovian system. Next is Lysithea. Lysithea was discovered in 1938. It is a tiny, irregular moon with a radius of about 18 kilometers. It is a captured asteroid, a piece of ancient rock that has been orbiting Jupiter for billions of years. Its orbit is slightly different from Himalaya and Elara, suggesting it may be a fragment from a different part of the original body. And there is Leda. Leda was discovered in 1974. It is another small, distant moon with a radius of about 10 kilometers. It is a fragment of rock caught in a slow, distant orbit around the giant planet. It is the smallest of the four main members of the Himalaya group. There are more in this family. Dia, discovered in 2000,